So what have we learned from all this? Well, we've learnt that if we have a cable of uniform cross-sectional area, the tension at the top per unit area, the tension per cross-sectional area, needs to be about 8 by 10 to the 10 newtons per square meter. Whereas in fact, really strong lightweight substances like Xylon have values of about 6 by 10 to the 9 pascals. So it looks, unfortunately, as if the materials we would need to build a space elevator are about 10 times stronger per unit weight than we can actually produce at the moment. Does that mean that space elevator ideas are dead? Well, not quite. In fact, there are many people working on these ideas. One way around this is, instead of having a uniform thickness cable, have one that tapers outwards. So you've got more cross-sectional area at the top to support the small amount at the bottom, which is where most of the gravity is. And that can get you quite a bit back. It doesn't quite get you everything you need. However, there are certainly possibilities to make materials stronger than things like Xylon or Kevlar. For example, carbon nanofibers. You can only build them in lengths of a few millimeters long, but they have ratios of tensile strength over area that can be orders of magnitude above this. And so if you could actually fabricate something made out of carbon nanotubes or some sort of atomic structure like that, you could quite straightforwardly build these things. Of course, it's a bit of an engineering challenge going from lengths of a few millimeters to 40,000 kilometers of the stuff. There is another possibility which has been speculated, which is that instead of having your Earth spacecraft up a geostationary orbit and then having 36,000 kilometers of cable, you have your Earth and a spacecraft in a low Earth orbit, maybe only a few hundred kilometers up, and you have a number of rotating hooks coming out from it. And what you do is this spacecraft will not be hovering over one point on the Earth, it will be zooming around the Earth at a very high speed. But what you do is you get these hooks to rotate at such a rate that the ground speed of these things cancels out the orbiting speed. So what happens is it's like a wheel rolling around the side of the Earth. And each of these, they're called skyhooks, as viewed from the Earth, will appear to dip down and then go back up again, much like a dot on the side of a wheel on the road. And what you do is you fly your aeroplane underneath and you hook your payload onto the end of this hook, which then yanks it up into space. And that way you only need cables that are 1,000 kilometers long, which are well within the capability of modern engineering. So, not possible, space elevators, but intriguing and fairly close to being possible, at least in principle.